In this video, we'll look at reflections. Another word for reflection is a flip. So if you have a figure and a line of reflection, to create its mirror image or a flip, we need to place it in a certain spot on the coordinate plane and then flip it over the reflection line. So how that's going to look like is a reflection flip over reflection line. If the figure was, let's say, this way, then its flip is going to be something like this. So in any reflection, every point or every vertex will be the same distance to the reflection line and away from the reflection line. So the same distance to the point, away from point. This one from far away will transfer over on the other side. So the reflections can be over vertical line and horizontal line. Let's say if I have the shape like this, then its reflection will be the flip over the horizontal line, same distance away. So this going over same distance away. So flip over the reflection line, but the same distance away. In other words, if I flip it over, it can be here because the reflection line is here, and the reflection over means same distance away from the reflection line. So it's the reflection over reflection line. And the example, let's say if I have the shape and the reflection line goes through the shape, then if I flip this over, that would be the image. So the pre-image and image will be flipped over. So the side of the figure that was on the left flips over to the right, and the side from the right flips over to the left. So if I match it up with the original figure, let's say that would be my original figure, and I line up, that's my reflection line, just so I can see the pre-image and image. I can reflect it over, and now the image is the opposite. The concept is the same. The vertices of the pre-image and image will be the same distance to the reflection line and away, to the reflection line and away. That corner is the same distance on either side. So let's see a few examples of reflections and how to draw reflections. First of all, a few vocabulary words needed. The reflection itself is a transformation that mirrors across the reflection line. So in a transformation, we need the reflection line, and the image and pre-image will be the mirror image of each other. The concept is moving every point of a shape same distance to and across. So we're going to count or measure the same distance to the reflection line and across from reflection line. So let's say pre-image, I will be labeling it in green, and that is the figure before the transformation. Let's say I'm gonna label ABC my pre-image. So the pre-image is the figure before the transformation. Then the image is the flip. In other words, this ABC triangle was reflected over the reflection line. Reflection line I'll be marking in pink. So this is a reflection line. By concept, every point has to be moved same distance. So point A is, let's say, distance 5 away from the reflection line. That means the point A prime will be the same number of units away across. So let's say 5, 5. It is the same distance away. Point B will be same distance to the reflection line and then same distance from the reflection line. So that would be B prime. And same goes for C. I have this small distance where C prime will be on the opposite side of the reflection line. So the image is the figure after the transformation. This is my image. So the pre-image, the figure before image, is where you end up. If I have a reflection line that is horizontal, let's say I have the triangle K, L, or N, T, I don't know, random, K and T. It doesn't have to be always in order of alphabet. So I have the T on the opposite side, T prime, same distance away. N will be N prime, same distance away, so to the reflection line and from the reflection line. N is the same distance across from each other, and K prime will be across from reflection line, same distance away. So in order to draw a transformation, you basically need to count the number of units to the reflection line and then transfer it over. After the reflection, the image will be congruent to the original pre-image, but the image will be flipped over. So the shapes will be always the same size, but flipped over, reflected from each other. The reflection is just like the mirror image. A few examples to notice. The most commonly used are reflection over x-axis and y-axis. So I have a reflection over the x-axis here, where the pre-image is LMNO. So this is the pre-image. And this pre-image was reflected over the x-axis. Reflected over the x-axis at the same time means that it's flipped over. So let's say if I use my transparency and I trace over the trapezoid, and then I trace my reflection line, because I need to see what the reflection line is, and flip over or fold over that reflection line, I see that the pre-image and image overlap. So my pre-image in green overlaps by flipping over the transparency paper with the image. A reflection over the y-axis means that the reflection line is the y-axis, and the triangle ABC, which is the pre-image, is flipped over the y-axis. To observe that movement, I can use my transparency again. And when you use the transparency, you have to make sure that you draw the reflection line. So I have ABC, my pre-image, and then when I flip it over, that triangle overlaps with the A prime, B prime, C prime, which is the image. So the pre-image, flip over, image. The move shows the same number of units. So let's check here point B. Point B to the reflection line is 1, 2, 3, 4, 5 units away. B prime to the reflection line is 1, 2, 3, 4, 5 units away. So point B is the same distance to the reflection line and away. Point A, 1, 2, 3, and point A prime, 1, 2, 3. So they're the same distance away. And then point C, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that is a perfect match. Every vertex is the same distance away to and away from the reflection line. Other examples of reflections can be over y equals numbers, or all the horizontal lines that are going through y, such as this example right here. I have y equals 4. So this image shows a reflection over the the reflection line y equals 4. And let's see, the pre-image is RST. If I transfer on the transparency and draw my reflection line, which is given by the problem, y equals 4, and then you flip it over, it is a perfect match of the pre-image and image. So we have a triangle RST, which is pre-image, and then the reflection R prime, S prime, and T prime. Point R is 3 units away from the reflection line, so I have to make sure that R prime is the same distance. Point S from and to the reflection line is 1 unit, and point T and T prime are 3 units away from the reflection line. So the reflection line is showing what across the figure was flipped over. Or the reflection line can be over equations with x equal number. Those are the vertical lines going through x. So in my example right here, I have the reflection line going through x equals 5. So the equation of the line x equals 5 is a vertical line going through x. 5. That means that all the x coordinates on that line are 5. And the pre-image RST is reflected over the line x equals 5. So what that means is I have my pre-image RST, my reflection line x equals 5, and when I flip it over, the image is shown by the reflection of RST by R prime, S prime, T prime. Vertices S are 2 units away, 2 from each other, from the reflection line. T and T prime, unit 1, and R 1, 2, 3, 4, and R prime 1, 2, 3, 4 are the same distance to and from the reflection line. And see a few examples how to actually draw a reflection. We have 2 examples here on this page. And example number 1 says reflect the figure over the x-axis. It means that the reflection line or the mirror is the x-axis, and what has to happen is this triangle needs to be flipped over the x-axis. So the vertices A, B, and C have to be the same distance flipped over. So one way to see that in motion is to use the transparency and trace over the triangle and the reflection line. That way you see where to fold or flip over, and then you can get yourself an idea of how the triangle is going to look like. So that helps brain understand a little bit how the flip looks like and how the triangle will look like on the opposite side. By definition, we have to move every point of the shape same distance to the reflection and away. So that means that point A, I have to have 1 unit away and label it right away A prime, because A is 1 unit to the reflection line, so A prime has to be 1 point away. B, again, is 1 unit to the reflection line, so B prime will be 1 unit away. And C is 1, 2, 3, 4, 5 units to the reflection line, so it has to be 1, 2, 3, 4, 5 units away. And that is my triangle. I'm going to connect the vertices A prime, B prime, and C prime. and this one will be my image. A good idea till you get better is to use the transparency to check if your image is in the proper location and all the vertices are transferred correctly. Image A prime, B prime, C prime shows the reflection over the x-axis. If I need to reflect the figure over the y-axis, then y-axis my reflection line, and all the vertices or all the points of the triangle ABC have to be transferred over, flipped over the y-axis. So that means that I have, let's say, point C 2 units away. That means C prime has to be 2 units away. Point B is 3 units away. That means B prime has to be 3 units away. Point A is 1, 2, 3, 4, 5 units away. 1, 2, 3, 4, 5 should be A prime. So if I connect my vertices, A prime, B prime, and C prime, we have the image reflected over the y-axis. We have to have pre-image and image congruent. Corresponding sides and angles will be exactly the same. So the length of AB is congruent to the length of A prime, B prime. The CB, C prime, B prime, they have to be same exact length. And then AC and A prime C prime are same exact length. The angles, the corresponding angles, are going to be congruent as well. In order to check if we want to make sure that everything was done correctly, another idea is to use the transparency. Here's my reflection line, and then the triangle ABC, and if I fold over my reflection line, the pre-image and image overlap. So thinking about what happened from here to there, pre-image to image, perfect match.